Thank you. This has been a great day today. I've been listening to all these talks, and so many are so inspirational with everyone talking about what it is that drew them to the space industry. And it made me think today about what is it that I'm an industrial engineer and an operations researcher, why am I drawn to the space industry? Why have I been doing this for 20 years? And I realize it's because I love problem solving, and working in the space industry affords me the opportunity to work on some of the most challenging and the most interesting and very unique problems. And today I'm going to talk to you about one of those interesting research problems that we were asked to solve. So we had a client who came to talk to us, and she said, I keep commissioning forecasts and buying forecasts and talking to experts. I need to know what technologies are emerging in the future, but I don't have a good feel for if what I'm getting is worth the money that I'm paying, or if it's giving me good data so that I can make decisions on it. And we thought about that, and I said, now, that is an interesting problem. How can we identify factors that improve the performance of forecasts? And right now you might be thinking, well, that's not a hard problem, right? Get some forecasts, see if they happen, run your stats. But it turns out this is a lot harder than it sounds, because not all forecasts are created equal. So many forecasters use very vague and ambiguous language. So while we were in our massive data collection phase so that we could get enough forecasts to run statistical analysis, we ran into the problem that some of these forecasts were actually so vague that they couldn't be assessed, or they had enough vague language in them that we needed to make sure we came up with a consistent method for interpreting them to ensure that all of our evaluators were evaluating forecasts the same way. So what we ended up having to do was come up with a process for interpreting the forecasts. So forecasts, for them to be accessible, they had to have a specific time frame. They needed to have a specific prediction event, and we needed to know the technology they were evaluating. So some of the problems we ran into is you're like, oh, well, time frame, that's easy, right? Someone predicts something's going to happen in 1985. Well, it turns out a number of people would predict that something is going to happen shortly, in the coming years, in the near term, in the not too distant future. And so we had to figure out a way to ensure that all of our evaluators evaluated those the same. And so we would first go to the document and say, is there any clues in this document as to what they need by the not too distant future? And if that was not in the document, we developed for this study what we called our standard language lexicon. And that was literally a list of terminology, words that are often used in forecasts that are vague or ambiguous, and we had to define them. Another interesting example is when it comes to predicting the number of things, like say someone was going to predict the number of small-sat systems on orbit. You might get someone who says, oh, well, there will be a few of them in the coming years, or there will be several. And so we actually ended up having conversations with the whole team and the client sitting around the table trying to decide what does several mean, because it seems really easy, right? To me, I was like, oh, 7, that means 7. But of course, not everyone agrees with me. And so we ended up having to define it as, well, several is about 5 to 10. But it turns out, well, if several is 5 to 10, how many is multiple? And how many is a multitude? And so we had to define all of these terms so that when it came time for the verification process, we had a concrete forecast statement with a concrete prediction event that could be evaluated. So that, after having all these kind of interesting conversations, another one that was interesting was the actual prediction events. A number of people would say something would become available. Well, what does available mean? And is that different from commercially available or widely available? And so these were all very, very interesting. And then the next step was verification. So we actually managed to, through scouring our own bookshelves of our colleagues, deep web searching, regular web searching, we came up with over 2,000 forecasts that we deemed could be assessed in the study. And the next step was the verification phase. And so we had our team of evaluators that would take a forecast, and they would have to determine, one, did the event occur at all? Were they realized? We did have some forecasts where the event never occurred, as an example, but a forecast from 1969 that predicted that it would be likely in the 1985 to 1986 timeframe that we would have commercial hypersonic airliners. Well, we still don't have commercial hypersonic airliners, so that is an unrealized forecast, and we can't measure the error of it. It just simply didn't happen. So we had a number of those forecasts that were just unrealized. Then we also had to determine if it did occur, when did it occur, so that we could calculate the mean error and see if people tend to overestimate or underestimate, or how was it successful? Was it within the forecast time frame? And we required our evaluators to try to find 2 reputable sources for all of their verifications. If you could only find one, we would then call in some technical experts to try to corroborate the source to make sure that we were confident in what was successful and what was a failure. So now we've got this huge pile of accessible forecasts. We managed to verify over 1,000 of them. Now that doesn't mean that all those other hundreds were bad forecasts. It simply means we could not find source data to verify whether or not the prediction occurred in the right time frame. So we do in fact have an enormous, it's actually a publicly available data set of forecasts. So if there's anyone out there with just a thesis that they're working on and they need a huge data set of forecasts, so let me know. So we went into the verification, we verified as many as we could, and we found some interesting results. So the first thing that we looked at was, for all of these forecast methods, were they better than a random guess? And we discovered that 6 of our 8 forecast categories were in fact significantly better than a random guess. However, gaming and scenarios and qualitative trends, we could not say they were better than a random guess. Then the next step was to look at the actual accuracy of the forecast and say, were any of these methods statistically better than the others? And it turns out that both quantitative trend analysis and models, which is also a quantitative analysis, were both significantly better than all the other methods of forecasting, and that includes the different expert analyses. We also looked at some other factors. We looked at the time frame. We had short-term, medium-term, and long-term forecasts. Short-term forecasts, 1 to 5 years, were significantly better than medium and long term. With the medium and long term, again, we couldn't verify they were better than a random guess. We looked at a number of other factors too, in the hopes that we could come up with a predictive model. We looked at things like the maturity of the technology, the complexity of the technology, the source of the publication, the geographic region that it was forecasted for, but we actually couldn't find any predictive variables amongst the others. So it was just the methodology and the time frame that gave us the actual predictive variables. So what does this mean to everyone? So we use forecasts all the time to make very important decisions, right? The government might want to look at when a new technology is going to emerge to avoid technological surprise. We might want to also look at how the pace of innovation for a particular technology is moving so that we can make or buy decisions. In commercial industry, we often look at markets for specific technologies so we can gauge our competitive advantage and decide how to position ourselves within a market. So what is this information? What does it tell us? And what it tells us is when you're holding on to a forecast and you're trying to decide, is this something that's going to give me good information, there's a few things you can look for. One, look for quantitative data. Numbers, numbers, numbers. You have to have numbers. Look for shorter time frames, nothing that tries to get too long. And another interesting finding was it turned out when we looked at the mean error based on when the prediction event was predicted for and when it occurred, most forecasters tend to be more pessimistic. And that was interesting. They tend to overestimate the prediction date. So there's a likelihood that your forecast event might happen a little sooner than predicted. The other things to look for came out of that whole assessment we had to do where we had to try to interpret these forecasts. Because if you have to do too much interpretation, you might be likely to misunderstand your results. So try to find ones that have specific language in them. And in particular, you really want to watch out for, we actually couldn't assess forecasts that said things like, this could happen in the next 10 years. Because when we really thought about it, could is basically saying it's got a 50-50 chance of happening. They're not making a good, solid forecast. You need at least likely to happen. So you have to look for specific language. And to make sure you don't misunderstand the technical aspects, look for people who use less technical jargon to make sure that you fully understand what is being predicted. And look for simple predictions. We actually found a number of forecasts that were very hard to evaluate because they would predict that an event would happen based on X, Y, and Z also happening. And that's extremely hard to evaluate. And as someone who is trying to understand a forecast and use the information in it, how can you be sure that X, Y, and Z are going to happen? So, in summary, what you want is 3 things. We want to look for short, specific, and data-driven forecasts. Thank you.